right, let's talk about changing midlines. We'll talk about changing amplitudes after we get done with midlines. So what do we mean by changing midlines? Well, let me just show you what we're going to do here. What we are talking about are functions like these. So we already know that if I've got a function that looks like f of t equals a sine bt plus c, that function has got a midline. In other words, it oscillates around the line y equals c. Well, it turns out that if instead of a constant we have a function, my sine function simply oscillates around that function. In other words, this is the line y equals mt plus b, and my sine function is oscillating around that slanted line. If I have got an exponential function added behind or in front of, or in other words, added to my sine function, my sine function then will oscillate around an exponential curve. Now, the rest of my definitions remain unchanged. In other words, if I compare the offset of my sine function to my midline at any peak or valley, that distance still gives me the amplitude. And if I look at the location on the x-axis of a peak, and I compare it to the location of a peak on the x-axis, that will still give me my period. And remember that b is equal to 2 pi divided by the observed period. And that is the internal multiplier. Okay, so let's jump right in and start building these functions. So usually we're going to do these in the form of word problems. So that's what we're going to start with. All right, so suppose I've got a population of elk that is currently averaging 2,000 this year. But we can look back in past records and see that that average has been growing by 4% per year. And due to seasonal fluctuations, the population oscillates from 50 below that average to 50 above that average. In other words, we lose 50 older animals, but we gain 50 babies. But we gain more than we lose, and we gain 4% a year. So what we want to do is find a function that models the number of elk after t years. In other words, if we continue with this pattern, what's my population going to look like at some point in the future? Okay, so we've got two components to what's going on here. We've got a changing average, and this changing average, represents the midline. And we've got the oscillation around that average, and that represents a sine. That means we've got a sinusoidal function. And we'll have to figure out all the components of a sinusoidal function. So let's just think about what's happening. We've got a minimum in the winter and a maximum in the summer. So let's call winter January and summer June. Why? January plus 6 is 7. July. Okay. So we're going to use a negative cosine because at time t equals 0, winter, we're at a minimum. So we know that my population, we'll call it P, is going to be negative 50. And we'll use a cosine because we're at a midline. What's my period? Well, you might think period is going to be 12 because 12 months, but we're talking about years. So my period, so amplitude, is 50. Period is 1. Which means that my internal multiplier is just 2 pi over 1, or 2 pi. And now we know we would add in our midline on the backside. So here's the tricky bit. Our midline is not a constant. Our midline is my 2,000 plus or times that multiplier that gets it to be increasing at 4% per year. Now, you may be struggling with this. So let me walk you through developing that. So what we're working with now is we're working with the average. So I'm going to say year and average. So in year 0, right now, my average is 2,000. In year 1, my average is 2,000 plus 4%, which means 0.04 times 2,000. And we could write that as 2,000 times 1 plus 0.04. Okay, so now in year 2, it's whatever I had in year 1, which means 2,000 times 1 plus 0.04 plus 0.04 times all of that, because it's a 4% increase. The easier way to write this is to realize what this means is that's 2,000 times 1 plus 0.04 from the previous year. But then we have to multiply by 1 plus 0.04 again to get that increase, which is 2,000 times 1 plus 0.04 squared. We can keep going, and either way, we're going to see that this is the function that represents our elk population in year T. Now let's take a look at what this looks like. All right, so we're going to graph this guy. So P of X equals negative 50 times the cosine of 2 pi x. All right, so let's change that. See, now negative 50 to 50, that doesn't make any sense because we're not going to have, whoops, sorry, my bad. We're not going to have negative 50 elk, so already we know that my function's not complete, right? Because I haven't added on. So in year 0, we've got 2,000. So let's do it this way. There we go. So in previous chapters, this is where we would have stopped. But now we know more. So we know that my population is actually increasing each year by 4%, which really means 1.04, because 1 plus 0.04 is 1.04 to the x power. So this is what it would look like. Well, you may be saying, well, that's not very exponential. Well, it is if you zoom out, right? You were expecting an exponential midline because that's an exponential curve at the end. So we can see that at year 0, let me just put on that midline function so we can see it. Whoa. Sorry about that. It took away my p of x equals negative 50 times the cosine of 2 pi x plus 2,000 times 1.04 to the x power. Okay, there we go. So let's go ahead and put on that midline function. So the midline function is the line y equals 2,000 times 1.04 to the x power. So what we've done is we've learned how to handle a function, an oscillating function that oscillates around another function. In other words, we've learned how to bend our sines and cosines. Very cool. Okay. So let's look at another example. Suppose I've got a table of values and I want to find a function that represents this table of values. Now, I've got a hint here. I've got a hint that I've got a linear midline. In other words, my midline is going to be mx plus b, or in this case, mt plus b. And my function is also giving me a hint that we're going to use a sine, and it gives me my internal multiplier. Now, if I've got my internal multiplier, I've got my period, and that's going to be helpful. So let's look at what I've got here. I know that my function has some magnitude times the sine of pi over 2t plus some linear function. Now, some things that are going to be helpful here. Let's think about this. I know that if b is pi over 2, that means the period of my function is 4. I also know I'm working with a sine, which means that I land on the midline. So my function is going to be on the midline at t equals 0 and a half a period later, so at 2. In other words, this point and this point are on the midline. So I know that my midline, my mt plus b, passes through the points 0, 5 and 2, 9. Oh, well, okay, we can do that because we know how to write the equation of a line that passes through 2 points. I know my slope is 9 minus 5 over 2 minus 0, which is 2. So my midline looks like y equals 2t plus b. Now it turns out that since I've got a 0 value, 0 in the x spot, I know my y-intercept, 5. So that helps me because let's put that midline on there. Y equals 2x plus 5. And I'm just going to make him dotted. Whoops, I need a 2x there, don't I? There we go. And let's go ahead and put my points on. So I've got 0, 1, 2, 3 for x's, and 5, 10, 9, and 8. Okay, now I can see that I'm on my midline at time is 2 and time is, or excuse me, at t is 0 and t is 2. And I'm going to actually give this thing a name. I'm just going to name it m of x. M for midline. Okay. And I did that because I want to know what is m of 1. And this is just an easy way to get Desmos to do that for me. So 7, which means that the point 1, 7 is on my midline. But where's my function at that point? My function is up there at 10. So what that means is that my sinusoidal curve is 3 units above my midline. So in other words, here I'm up 3 from my midline. Let's see what happens when I'm at the next point that I know. So what is my midline value when t is 3? That's 11, which means that the point 3, 11 is on my midline, but my function is down here at 8, which means that at that x, my function is 3 units below my midline, which means my amplitude is 3. And I've got enough now. That means my function is equal to 3 times the sine of pi over 2t plus 2t plus 5. This part gets my oscillation. This part is my slanted midline. So let's just put that on Desmos and check ourselves. So I think that my function is 3 times the sine of 2 pi x, no, sorry, pi over 2x, because that's what they gave me, plus my midline, which I'm just going to do this way. Now, when you're giving this as an answer, I did that for a reason. We'll talk about that in a second. This would be what you would put into my open math. I wanted to, on Desmos here, illustrate to you that the thing that is added on the back of my function is the equation of the midline. And that hit all of the points that were in my table, right? Okay. You'll notice my points are not necessarily at the peaks and the valleys. They're pretty close. But this happens. It's okay. It works out because the thing goes through all of my points. All right. In the next video, we're going to talk about changing amplitudes. So we'll see you again in a minute.